NeosVR is compatible with a number of different VR controllers. If you're wondering what buttons that I'm using relative to your controller, just refer to this part of the video. To make this tutorial easy to follow, I recommend navigating to this world space that I've created, which will contain this exact same video along with all of the objects and examples that I'll be covering along the way. So now that we're here in this expertly crafted, extremely high detail, deluxe, premium tutorial world, let's begin. Tools in NeosVR are physical objects that you equip. Each one either performs functions specific to them and/or alter your controller menus to give you additional tool-specific options. All of Neos's main tools can be accessed through the inventory system. I'll be covering topics related to the two main editing tools in Neos, which are the Developer and Logix tooltips. Because of Neos's extremely modular design, this enables users to modify the properties and behaviors of just about everything directly within a VR environment. You can create user interfaces, create and animate materials, and make things interactive. Generally, if there's a type of functionality that you need in Neos that's missing, chances are very good that you can build it yourself. We'll take a look at the Developer's Tooltip and its various uses first. In the majority of cases, you'll want to use this tool to gain access to the properties of an object. To do that, just point the tool at the target and press the secondary action button. This purple highlight tells us that a developer's tooltip has this item targeted. If you ever need to move, rotate, or scale an object in a very specific or precise way, these gizmos allow you to use the trigger button to make fine-tuned, axis-constrained adjustments. Only the developer's tooltip can affect these handles. If I attempt to move them with my offhand, it won't work. Most of Neos's tools behave in this way, so if something isn't working for you, make certain that you are using the correct tool for the task. Some tasks may require you to unequip a tool or use a tool-free offhand to accomplish. Let's get back on topic here. So now that we have this object selected with the developer's tooltip, we can open the controller menu and select Open Inspector. If you are familiar with any 3D application, I want you to think of the inspector as your scene editor or outliner. Essentially, things in your scene are listed in this left area here, and the properties of whatever you have selected is listed to the right. Note that you can grab and resize these panels as needed. Something you're going to notice, though, is that nothing happens when you use the trigger button on this panel. It is because the developer's tooltip cannot be used to interact with this panel. So in this case, I either use my left hand's trigger button, or what I usually do is point the tool towards my opposite hand's tool shelf and press the trigger button to attach my tool there. Tools can be equipped or unequipped in this way, and it's a very convenient feature that's really going to come in handy later. Okay, so in the inspector panel, I can hit this up arrow symbol to navigate to this object's parent, and the parent happens to be the root for the entire scene. In other words, the root contains a listing of every object present in this world. Double pressing the trigger button, much like you would your left mouse button, selects the item and displays its properties, which can be edited just like in any other application. Copying and pasting is something that I frequently do. By pointing your laser at any field and holding the grab button, that value appears over your controller. When you let go, that value is copied to whatever the laser was pointing to. This same concept also applies to how you parent one object to another. So if I make this blue box a child of this red box, we're left with this result. The blue box is now attached to the red one. Of course, there is also a built-in tool for this called the glue gun, but there may be times where you want a bit more control over the hierarchy. Now I'd like to show you something else about the inspector panel, and we're going to use this simple cube as our example. Just about every single object is nothing more than coordinates plus a series of components. And by components, I mean these sections here, box mesh, mesh renderer, etc. Each of these is performing a very specific function. So the box mesh creates the mesh renderer renders the mesh and applies a material to it. The box collider is what determines what dynamic elements can pass through it. Right now, the main thing that this is used for is the user's editing lasers. Without this component, users can't move or grab an object without a developer's tooltip. Now, this is not something that you typically have to set up or worry about. Just know that it's there for later reference. I'm going to cover value copy in more detail, but here it is assigned to the box collider so that its collision boundaries will always be the same as the box mesh. And finally, we have grabbable, which, not surprisingly, it allows you to grab this particular object both with the laser and physically. There are quite a few components that you can add to any object in order to give it unique properties. By using the trigger button on Attach Component, we're given what I will admit is an overwhelming list of things. Fortunately, they are categorized at the very least, and I'll go ahead and add a spinner component for the sake of simplicity. With this component added, the values that it contains can be modified as desired. As you look through this component list and experiment with things, just know that many of the most useful functions can be found in the transform category. One last thing about the inspector panels that I would like to cover concerns properties that require any kind of reference. Say that we want to make one object always face another object. This can be achieved with the LookAt component. The problem that we run into is that this component requires a target to do anything useful. In order to assign a target, you often need two inspector panels. Simply hold the grab button while your laser is pointing at an item in this list, move your laser over the target field, and release the grab button. Other fields which may require a position, a material, or other type of property all work in this same way in terms of assignment, and it's a good thing to be made aware of. Alright, so all this is nice, but sometimes handy components aren't enough. That's where this tool comes into play. NeosVR features a node scripting system called Logix. This fancy doodad here is a Logix tooltip. This gives you the ability to visually program effects and behaviors directly in a VR environment. It is completely interactive. You see the effect of your changes as you construct your setups. Something that everyone is likely going to want to do at some point is make things appear or disappear. For example, my custom brush here has a toggle button that allows the user to hide its interface when it's not needed. What's that you say? You don't want to take the time to learn how to do this? Well, deal with it. I'm going to show you how to achieve this exact same effect with these Deal With It shades. If I pull up the inspector for this item, I want to draw your attention to this area here. Every object has this basic set of properties. The active checkbox is what determines whether or not an item is visible and can be interacted with. So we need something that can trigger this value on or off. If you open the controller menu for the developer's tooltip, there is an option to create new objects. This brings up a menu. Most of this is fairly self-explanatory, but what we're interested in are things related to user interfaces, which is located within the Objects category. I'll expose the inspector for this checkbox, and now we're ready to finally use the Logix tool. Every object and every component can have its parameters exposed by the Logix tooltip. Since we want to gain access to the active checkbox for these shades, I'm going to move my laser over the object's name, press and hold the grab button, move it away from the panel, and press the secondary tool button. Now for the checkbox. The actual function of this checkbox is contained within one of its components. If I toggle it on and off, notice that this value labeled isChecked changes accordingly. So, using the Logix tooltip, I'm going to grab the component, move my laser off the panel and press the secondary tool button. The parameters for this object's component are now exposed. From here, we can just use the trigger button to plug the isChecked parameter into active. Now this checkbox is determining whether or not these shades are visible. Notice how the active checkbox for the shades turned purple, or pink. This means that the value is being controlled by something else in the scene, and it cannot be changed here without removing the logic setup first. Let's make things just a little bit more complex here. Say that we want these shades to spin using a spinner component, but we want to allow the user to manipulate a slider to determine how fast they rotate in any direction. I'll add the spinner component first, then use the Logix tooltip to expose this component's parameters. Afterwards, we need a slider along with its inspector panel. Again, I want you to notice that when I manipulate this slider, the value field changes. So we're going to use this to determine how fast the spinner component spins the object. This is where a lot of beginners get stuck. You can't just plug the value of the slider into the speed of the spinner. This is because we're dealing with two different data types here. The reason for all the different colors and patterns on these panels is to tell us that these properties are expecting to be used with something very specific. If you ever want to display the value of most parameters, such as this speed value, you can pull the node out using the trigger button, and while holding this strand, press the secondary tool button. Doing this creates a display node. I'll do the exact same thing for the slider's value, and notice how the display changes dynamically as I move the slider around. With these two display nodes now present, we can clearly see the differences between the slider's value and the spinner's speed property. The speed for the spinner component consists of three bundled values, which are the x, y, and z directions. Observe as I alter the values in the inspector panel for the spinner component. The result is shown in this display node. So, essentially, both of these parameters accept decimal numbers, which math nerds will refer to as a floating point number. The reason why this output is striped is because it's expecting at least 3 numbers at the same time. We have to set up some extra nodes in order to make this slider value connect with this spinner speed parameter. In other words, the computer has no idea whether or not you want to plug this slider value into X, Y, or Z, and you need a way to communicate which direction is desired. I'll go ahead and move these displays aside. They aren't technically needed, but they are often helpful. Within the Logix Tooltips menu, there is an option to open up a node selector. It is here that we gain access to all of the different types of nodes that we can create. Although there's a lot of stuff to look at here, know that you'll likely only be using a small portion of these on a regular basis. The way this works is that you select a desired option by double pressing the trigger button, again like you would with your left mouse button. I'll select Display, for example. Now I can point my Logix tooltip away from the panel and double press the trigger button again to create a display node. Some nodes like this one can accept multiple types of data, so as soon as you plug something in, its color will change appropriately. I can even grab the isChecked parameter and view its result here. This result can only ever be true or false, Math nerds call this one a Boolean. I have more to say on data types, but let's get some results first before I bore you too much. What we need out of the node menu is within the operators category. It is called packxyz. This allows you to explicitly define 3 float values. Math nerds call this bundle of 3 decimal numbers float3. Before I start plugging stuff in, watch what happens if I hover my Logix tooltip over these inputs. It tells us specifically what this node will affect. In this case, the top input affects X, the middle input affects Y, and the bottom input affects Z. Notice how it corresponds with this display. Knowing that, I'll plug this into the X input and hook the node into the spinner's speed value. I should note that if you don't plug anything into the other inputs here, they are assumed to be 0. I can actually pull out a strand and press the secondary tool button if I want a fast way to manually input a value if so desired. Alright, this seems to be going way too slow, so we need to increase the slider's value range, so I'll just set the maximum to 90. We can change the direction in which these shades are spinning quite easily. Pressing and holding the trigger button will cause a red line to appear. If this red line intersects with a connected node, the connection gets severed. The final result is an object that we can toggle on or off and control the spin speed of. Right now, this node setup is kind of an eyesore, and ideally, it is not only hidden from the user, but packaged neatly so that it can be easily saved into the inventory. Here's how I deal with that problem for the time being. Using the developer's tooltip, create a new empty object. This will act as the container for our entire setup. I'll go ahead and rename this to Deal With It. This plus button here can be used to create additional empty objects. We need one more to contain all the Logix nodes. Making sure that nothing is selected with the developer's tooltip, open the inspector for the root of the entire scene. We want to make the shades, the checkbox, and the slider all child objects of the Deal With It container. With that done, all of the created Logix nodes must be placed into the Logix container. I do expect this process to be simplified over time, but for right now, this is the most reliable way to package everything up. You can confirm whether or not all of the nodes have been placed by disabling the Logix container's active checkbox. Okay, so we've covered the developer's tooltip functions, and we got our feet wet with Logix. Let me go over some important odds and ends before we finish here. There may be times where you want to work with a model's animation, or a video, or an audio clip, and you want control over how it plays back. Here, I've imported a simple character walk animation. In some cases, it may be difficult to select the character with the developer's tooltip as the character moves around, so I'll just access the root of the scene and select it that way. Anything that is animated in any way will always contain some kind of playback component. Notice how you can actually control the timeline here, but in most cases you're going to want to create something that's a little bit more accessible. Same as before, I'll expose this component's parameters with the Logix tooltip. Within the node selector, there is a section specific to playback, and you're always going to want a playback state node in order to get access to information regarding anything that is controlled by a timeline. Again, by hovering over the outputs for this node, we'll observe that we get various types of information. I'll go ahead and display the results of these outputs so that we can see them visually. Just for the sake of example, let's assume that our goal here is to create a slider that lets us control the speed of the animation and even play it backwards. I'm going to set this up essentially the same way that we set up the spinner. We're given a set speed node, so logically you would think that by connecting the value to speed and the speed to playback would work, but it doesn't. The slider isn't doing anything. Time to quit, I guess it's broken. No, I'm kidding. Some nodes require you to explicitly tell them when they should make changes, and this is one of them. This white input needs something in order for this set speed node to do anything. The type of node that we need to add can be found in the flow category. Things in the flow category often are used in tandem with logic nodes. With fire on change, we can tell this node to activate whenever the slider is manipulated. Something else you may want to do is reset things. It can be difficult to get this animation playing back at its normal rate after moving the slider. So what we can do about that is create a button that sets the animation speed to 1, its normal play rate. Buttons have what is called a flash index. Every time the button is pressed, it increments this value by 1. We can use this to detect when the button has been pressed. Another node that we need that I feel is extremely important to know about is the write node. What write does is that it provides a way to change a value. It can accept multiple data types, and because the slider value is a float, or a decimal number, we need a float input, which I'll set to 1. This write output can then be plugged into any compatible input. Now when the button is pressed, the speed of the animation is going to be set back to 1. So knowing all this, you could expand on this setup to create buttons that manipulate 3D animation, video, or audio clips in very specific ways, whether it's for presentations or triggering animations that are meant to be used with interactive content. Okay, there's one more thing that I want to go over, and that's the topic of logic. In other words, if something is true, do this. If something is false, do that. Things like that. We can actually use this playback setup to demonstrate this. Let's say that halfway through the animation, we want the speed to be fast. Otherwise, we want it to be normal. So first I'm going to dive into operators and select the greater than sign. The idea is that this node can give us an output of true or false based on what is plugged into it. The big playback node has an output that gives us the normalized playhead position. This means that it just uses a number between 0 and 1 to determine the beginning and end of the animation. A value like 0.5 would be the middle of the animation. So I'm actually going to plug this into the top input, and I'll pull out a strand, hit my secondary tool button, and enter in a value of 0.5. If we display the result, notice how it is false on the first half of the animation and true for the second half of it. We can use this with the conditional node. This allows you to define what value is provided if a condition is true or false. If I hover my Logix tooltip over this node, we'll see that the top input is what is provided if the condition is true, The middle input is what is provided if the condition is false, and whatever is plugged into this bottom input is what decides which one of these top two values are used. So I'll plug our greater than result into the condition input. This tells it whether it's true or false. And now we want two float numbers, one for the onTrue input and one for the onFalse input. On true, the animation is going to play at its normal rate. On false, we're going to have it play at, 5 times its normal speed. If I make a display here, we see that the value alternates according to the true or false result it's getting from the previous node. From here, we'll need to use a fireOnChange node to detect when the true or false condition changes, and a write node to actually make the change that we want. And with everything plugged in, what we have is an animation being driven by simple logic. Thanks to NeosVR's modular approach, what I've discussed here can be applied to just about everything. So that's it for now. I hope you found this tutorial helpful in getting you started with Neos's development tools. I'll likely post some smaller, more specific videos in the tutorial world that I've created, so keep an eye out for those.